chapter 8. Then next week, just for the review session and for presentation for the project. Also, today we may finish a little bit early. I have something to do, then we may finish around 4:15 or something like this. Good afternoon, Quân. Good afternoon, Uyên, Thư. Good afternoon, Khoa, Vice President. How are you doing? How about the project? How is it going? It's good. Yeah, if you have the new idea, then follow your new idea. If you like you're not confident for the new idea or the new project, you can follow the project on the analyze the global warming in Vietnam. So actually, you are learning, we are learning, then do not pay much attention for the result. Pay for attention what we learn during doing the project. Because when you do the project at our level, we may make a lot of assumptions. Then sometimes the results not as our expected. Then it's okay. Just report what we observe. Then analyze the reason why it's lead to the ridiculous result or something like this. This is okay. Good afternoon, anh Tư. Good afternoon, Thương. Questions whether you must have the hypothesis testing in your project. You don't. As we mentioned in the projects instruction we send, you can choose whatever topics. So for example, if you choose logistic regression or something, you may not have the hypothesis testing. Like any topic in statistics. So some topics they contain hypothesis testing, but some topics they do not contain. Then you don't have it to. So the answer is you don't have it to. Of course, if you have a more result, then it will give the additional impact on your report, on your result. And any further questions for the project? Okay. We start. Firstly, I want to announce about the content for the final exam. Oh, I should record.
Recording in progress.
For the final exam, I will send the announcement, official announcement soon when we have the date for the final exam. But so far, we will have the brief announcement, the content from chapter 5, parameter estimation, chapter 6, hypothesis testing, chapter 7, regression, and the current chapter, the last one, analysis of variance, chapter 8. So you have a 4 chapter. The format, similar to the midterm exam. The part 1, multiple choice, part 2, rating. The time for the rating session is longer, but the format is similar. Any questions so far? So you have a 2 part, part 1 for multiple choice questions and part 2 for rating questions. And this is similar to the midterm exam. We have more time. The total time is 120 minutes. Okay, we briefly review what we discussed last week. Then we finalize, we finish this chapter, analysis of variance. Then we're done for today. And next week, for the first part, we will review, we will do exercise. I will send you some exercise for the reviewing part. For each chapter, I will choose some, I will select some key problem. Then we practice. And for the second part, you have the presentation for the project. Okay, I should try here the plan for next week. So just remind you, we will review the first part. By doing exercise, I will send you the links of exercise later, maybe next week. And the second part, we have the presentation around. Actually, I don't limit the time, but the time basically around 15 minutes for each group, because if you want to present more, feel free. But briefly, do you need more time? I guess 15 minutes is enough. Okay, we briefly review the stuff we discussed last week. Last week we done analysis of variance. We done one factor analysis of variance. Actually, it's a little bit fast. We also done the regression part, chapter 7. So we review a bit about one factor analysis of variance. This is the problem we want to study the factor, say the factor gas is affect the result. For example, the result is the mileage or not. So for the factor, we have the one factor here. I mean, you see, gas. We may have 3 kinds of gas, and we want to understand whether the gas affect the result or not, which is the mileage. So for each gas, we have the data, and we will compare we will use the analysis of variance because we want to compare the difference between the mean of each kinds of gas to the grand mean, the mean of all the data. And that's why in order to compare the values here, we need the concept of variance, because we want to understand the variability of the data of each column to the mean of all the data. And in order to analyze the variance is small or large, we have the test statistic, and we want to, if the test statistic is a scale with the variance, if it's a sufficient large, then we reject it. So if the test statistic is sufficient large, it means we may have some column. It's the data may be different, significantly different to other column. It means we may have some gas. It means we reject the conclusion, the null hypothesis, all the gas are the same. So it means we may have one column or two columns. The data may be quite different with other. It means we should consider the factor gas to the mileage of to the result, and in this case the result is the mileage. If we reject it, it means we may consider the effect of gas in the mileage. So we done with the example here, and in this example we kind of accept. We do not have enough evidence to reject, because our test statistic is less than the threshold value. And in the section analysis of variance, you always use alpha is 5%, even though the question does not give the significance value alpha, but normally we use alpha is 5%. And in the table, we always use alpha is 5%. Okay, and we summarize the results of one factor analysis of variance here. We compute the test statistic. The test statistic is proportional to the variance of the mean of each column to the variance defined by the mean of each column to the grand mean, the total mean. Okay. If you have n data, then the variance like this. Maybe we use the notation m here for consistent. If you have an m column, then you have the variance like this. And you compare the test statistics with the threshold value. And the key to reject is if the test statistic is large enough, it means the one of the key factor is the contribution of S squared is large, and the data is also large. For doing the homework assignment or for doing exercise, n is small. So this is inconvenient. It's linked to the factor that even though S bar square here is large, however, you need to accept the null hypothesis, because the n here, when you do the exercise, when you practice the exercise by hand, n is small, because people want you to make the simple calculation. But in practice, n is large, and it's easy to lead to the conclusion reject the null hypothesis when S bar square is large. So there is this is the main difference between a practical problem and when you do the homework assignment or you do the small problem by hand. That's the n. Okay, and in order to compute the p-value, you need to use the F distribution. Okay, last time I think we done this example. Now we go to the two-factor analysis of variance, and we done for today. So suppose we consider the example, the score. The score, we have two factors affect on the scores. The level of difficulty. For example, for each week student, for each month student take a different exam, or you take the exam IELTS or TOEFL. Each time, each month student take a different exam. and maybe the level of difficulty affect the score. And of course, the student, the different student may have the different score, like student on the top or in the middle or something. So here we have a 5 student and we have a 4 exams, and 5 student, each one they take 4 exams, so they should have a 4 score. So totally you have a 20 scores here of 5 student and 4 exams. And we want to study whether the factor students or the factor exams affect the scores. So before doing this, you can guess the student, the factor student may affect the score, should affect the score. But if this is a fair exam, if the exam is fixed but organized for different time, then it's good if the organizer prepare the exam such that the level of exam does not affect the score. But this is what we guess, because we don't know actually what happened here. We know the bubbles of the organizer. Maybe they can change the level of difficulty for each exam. So we base on the data here. So firstly, we discuss about the notation. In general, you have here you have a 2 factor. Okay. Sorry, here you have a 2 factor, and the factor is exam and student. In the factor student, you may have a many students. In the factor exam, you may have a many exams. And the notation, the data can be write out in the matrix of m rows and n column. Okay, so for one factor, you may have n data or m data for 2 factors. So totally you have a matrix. So again, each point here, the score here is value here. This is the score this is the score of a student take 1 exam. So it has 2 properties. Okay, and we want to study whether the exam or the student affect the score. So what I want to say is, if you want to take the IELTS, then you expect the quality of student may affect the score, but you may affect the exam. The level of difficulty should be the same for all the exam 1, exam 2, exam 4, and exam 100. But in general, for all the exam, maybe the organizer maybe change the level of difficulty. If they for each time they apply the different score, the different threshold score for different bubbles. Okay, for we let mu I be the mean of the row I. So for each row, let me summarize the data here. Maybe I summarize here. Okay, here. Let you let mu I be the mean of the row I. So the mean of the row 1, you have the value mu1. The mean of row 2, you have the value mu2. You can let beta 1 be the mean of the column 1, and beta n be the mean of the column n. Okay, so it's mean the expected value of the xij equal mu I, and mu is the mean of all the value on or the mean of the row, or mu here also the mean of all the data, or mu here also the mean of all the column. So for mu here is so-called the grand mean. This is the mean of all the data. And each data here, each data here, the mean here, we can decompose. We can decompose into a constant, the mean of all the data, and we expect we have the effect from the row, and we have the effect from the column. That's this value depend on I and j, and we expect we have a constant. It does not depend on I and j, and we decompose. Is it the sum of the grand mean and alpha I? Alpha I is the deviation from the grand mean to the row I, and beta j is the deviation from the grand mean to the column j. So if alpha I and beta j are 0, then you have a no deviation. This means you have a no effect from the row or from the column. So for example, the row the row stand for the types of the exam, and the column stand for the quality of student. Of course, each student take the exam, you may have the different scores. Okay, so the row stand for the I index and the column stand for the j index. Here, if alpha I equal 0, it means you have no effect, the deviation from the grand mean to the row I. The row I stand for the exam I, and alpha I equal 0, it means you have a no deviation. It means you have a no effect. Or beta j equal 0, it means the deviation from the grand mean mean mu to the column to the student is 0. It means the quality of the student in this class are the same. Okay. So we denote when you measure the data, when you have the data, you denote the mean of each row is xi dot. The mean of each column is xj dot, x dot j, and the mean of all the data is the x dot dot. So this is the actual mean when you measure the data. Okay. For the estimation of the for the estimation of mu hat or alpha I hat or beta I hat, is a kind of additional reading. So you can skip the next two slides. I want to go directly to the problem. However, I want to emphasize the notation in this part only. So suppose you have the data for the student and the examination. You take the mean of the first row, you call xi dot. So for example, the number 72.8 here is the mean of the first row. The mean of the first row, this gives you xi dot. So it's mean xi dot is the sum of x1 dot, x11, x12. So x1 j over here you have n, and j varying from 1 to n or m. Let me look at the notation. n column. So suppose you have an n column and m rows. So in order to do the problem, you compute the mean of the first row, the mean of the second row, the mean of the last row. This problem is kind of complicated, so we should discuss the notation carefully. And you compute the mean of the second column, the columns, the first column, the second column, and the last column. So you have a 5 means on the column and 4 means on the rows. Okay, and this value just the total. So in order to do the two-factor analysis of variance, you need to make subtable. At the beginning, you are only given the table at the beginning here, but you borrow one more column and one more row for the column of the means and the rows of the means. Okay, and you compute the grand mean. This is the mean of all the data of the matrix. So the x that here is also the mean of the last column here, or the last row here, or the mean of the last column here. So the mean of this also give x dot the mean of this column also give the value x dot here. Okay, and in order to study the effect of the rows or the column, we need to compare the mean of the mean of the columns. Here you have a 5 column, or the means of the rows. You have to compare to the grand mean here. So we go directly to the calculation. I want to skip the estimator for the parameter here. So you can skip this slide. We go directly to the problem. Maybe maybe it's better we show one computation. We go directly to one example, and we discuss back to the formula later on. Maybe this one. Okay. So before explain the formula, because it's not good if we go to the formula first. I can in parallel explain the one example and illustrate how to do. Again, you can skip some previous slide here. Is it just some introduction to estimation the parameter, but it's not the key point. The key point is what we discuss here: how to study, how to solve the impact of the factor. So we want to test the effect of the row or the effect of the column. They have the effect, significant effect or not. So suppose we have the data for the worker. We have 4 workers, and so one factor is worker and another factor is machine. So here 2 factor we want to understand is machine and worker. For the data exam and student, we will back later on. For the machine, we have the data of 3 machines. We collect the data of 3 machines. And for the worker, we have 4 workers. This means 4 workers here work on 3 machines. And we have the data. The data stand for the items produced. And we want to understand whether the number of items here is depend on the worker or is depend on the machine, yes or no. So we do the test at the same time. We want to make the answer at the same time. Okay, whether the worker or the machines affect the items produced here. So the number here are item produced. Okay. In order to do that, we borrow one more rows and one more column. So this is what you need to represent in the writing part. And I want to emphasize that in the writing part for the final, we may have the questions for analysis of variance. So you need to do the you need to pay attention how to write out the how to present the answer here. We compute you compute the mean of the column. So the mean of the column you call you compute the mean of the first row. You call x okay, this value you call x1 dot. This value so you compute the mean. This value you call x1 dot. This value you call x2 dot. This value you call x3 dot. You compute the mean of the first row, second rows, and third row, and you compute the mean of the okay, I can fill in here. The mean of the first row is a 39.5. The mean of the second row, and so on. 39, and so on. The mean of the third row is 43. Then the mean of the first column, okay, 39.3. And the mean of the second column, the 41. The third column, 42.3. And the last column, 39.33. Okay. And you compute the mean of all the data here, the mean of the matrix. In order to compute the mean of the matrix, we call x dot dot. The name is x dot dot. You can compute the mean of the column here, the mean of the last row here, or the mean of all the data. Is a 40.5. Okay. So the first step, compute the mean of the rows and the mean of the column. Oh, the mean of the rows, so we call x I dot, and the mean of the column, so called x dot j. Okay, so this value so called x1 dot, and this value so called x2 dot. This value so called x3 dot, because it's a row 3. So if this is row 3, you start by the number of the row, or this value we call x dot 1, because it's a column 1. That stands for me. So the dot here stands for me. Okay. Here you call x dot 2. Here we call x dot 3. So sometimes we say x dot 2. It means we are talking about the mean of the column 2. Okay. And here we call the mean of the column 4. So this is the notation. That stands for the mean of row, or the mean of the column. You may feel the notation here is a little bit complicated, but we have no more because the problem already complicated, and we do not see other similar notations. Okay, and in order to test for the difference of the rows, we compute the difference between the mean of the rows, So you have m rows. You have m rows, and you find the variance. You find the variance of the row. It's equivalent with the, you compare the difference of the rows to the grand mean. So this is the grand mean. Grand mean means the mean of all the data, and here you have the mean of the rows. This is the mean of rows i's only, and you scale by the parameter n here. The constant n here we scale just for the goal of doing the F test, to make it as the perfect F distribution. So we compute the mean. In this problem, we have m equal. In this problem, we have n equal 4 and m equal 3. M number of rows and n number of column. Okay, so here you have again you have n equal to 4 and m equal 3. 3 rows and m a column. You have 3 machines and 4 workers. Okay, here you have 3 rows. You have 3 rows. So m equal 3, and the row stand for the machines. The row stand for the machines, and workers, number of workers. You have 4 workers. Okay, because is 4 workers, and m is machines. 3. We have 3 machines. So this is stand for the variance of the rows. We scale by the constant because it's come from the data come from workers, and as error, the sum square of all the errors. It means the data, the difference of the data to the grand mean, the difference of the data to the columns and the rows. So the sum of the error here is stand for the denominator, the common difference, the difference of all the data. And if we make the test of this is the quotation, the quotient of the sum of the square of the row and the sum of the square of all the error. So the sum of the square of the error here is a fixed. This is the value here is a fixed for the row and for the column, and it stands for the whole difference of the data to the rows and to the column. So the test statistic is computed via the test statistic is a compute via the test statistic for the row. For the row in our problem stand for the machines. It's the quotient here scaled by the constant. By the constant m minus 1 and n. The constant here just play the role said that when we construct the theory, we remember when we construct a theory, we need some constant to make it perfect. The distribution, and in this case we want to make it as a perfect F distribution. We have a chi-square distribution over chi-square distribution, and we want to normalize. So the normalized is m minus 1 and n, and here is equal and here is equal m minus 1 times n minus 1. Just the scale to make it perfect F distribution. Degree of freedom on the top is m minus 1, and degree of freedom of the bottom. This is degree of freedom of the bottom is n, and here is m minus 1 times n minus 1. Okay. So so in our problem, and here is the degree freedom of the bottom is the m minus 1 times n minus 1 is the 2 times 3. This is 6. So degree of freedom of the bottom is 6, and degree of freedom of the top is a the top is a m minus 1. degree of freedom of the top is this is m-1. So in general, we need to compare with the test this with f of 0.5 m-1 and here, because degree of freedom of the top of SSR, this is just m-1. Okay, and degree of freedom of the bottom is n-1, and the top divided by the bottom is follow the F distribution with degree of freedom is m-1 of the top and for the bottom, and we reject or we accept the fact that the row stand for the machine affect on the quality of the product. The number of items produced is based on the test status is small or large. If the test status is large, it means there some row here they may have the significant contribution, and it's make the test status is large. So the test statistic is a compute via the sum of the square of the row. R stands for the row. Then divided by m-1 over the sum of the square of the error divided by n. We divided by m-1 or n is come from the formula, and why we have a such formula, because we need to scale. Like think about the chi-square the F distribution. The definition of the F distribution is come from chi-square distribution, and we divide it by the constant. So in this example, after we compute the sum of the square of all the error, then we make the division. Our test status is just 1.2. So we compare with the critical F value, and we have the test status is small compared to the F value. So in this case, we accept or we do not reject the null hypothesis. That's a we do not reject the hypothesis or the row are the same. So it means we do not reject the null hypothesis. The output is mean the defective item is unaffected by the machine. So the machine are the same. We accept this fact. Accept mean not reject or accept. Accept mean we do not have enough evidence. So as we discussed before, for doing exercise, m and n here pretty small. So in practice, we may reject, but in doing exercise, because the data here just a few data, and m here is small. So normally, if the data is very close, then we normally will accept the null hypothesis. And when the test is large enough, like when you have more data on the row, then more data on the row, because for each row here you have only 4 data, right? And if you have like for 40 workers, then you may reject, but here you only have 4 workers. So in this case, the sum of the square of the rows is not 38 here is not large enough. And for this case, we always use 5% level of significance. So alpha is 5%. Always for F-test. Here we can say F-test for analysis of variance. This means with this data, the quality of the machine are the same, or we do not have the enough evidence to reject. They are different. If you want to study the difference of the workers, then you compute the sum of the square of the column, sum of the square of the difference of the column. So this is the mean. This value is the mean of the chase column. Okay, and this is the grand mean. Grand mean the mean of all the data, the mean of the matrix. This is the mean of all the data of the whole matrix. So the mean, this is the variance of the column. It means you are studying the worker, because the workers, you have a 4 worker. It means you have a 4 columns, column 1 up to column 4. And you are computing the difference, the variability of the form means here. This is the number of defective items produced compared to the total mean 40.5 here. Is it small or large? It means you are studying the quality of the worker. So in this case, you make you compute the test statistic. Again, the test statistic, for the column. Is it the sum of the square of the column divided by n minus 1 over the sum square of the error divided by n. You follow the formula mentioned here. The test statistics. When you want to test the column or want to test the row, so you have the test statistics for the row for the column, and you compare the test statistics with the F distribution, the threshold value. So for this part, I believe it's better to have you do it on your own, because when you look at the explanation here, you may be confused or get lost. When you actually do it, then it may lead to have a questions. What should you do? So is it better that is it better to have you do in one example, of you doing one example clearly, and you can back to make the questions. So okay, or we can do it together. Okay, I think we can do it together in this one. So please compute the mean of the row, the mean of the column, and the grand mean. Then compute the sum of the square of the column. So in this problem, we have 3 fuels and 3 launchers. So we want to test 2 factors. One factor is fuel, and one factor is the machine. So we have a 2 factor here. One factor is called fuel, and one factor is the launcher, mean the machines. And we want to study whether there is the difference in the fuel or the difference in the launcher. The data here stands for the data here stands for the number of miles traveled by the mixer. So the mixer, it can use one of 3 launcher, or it can use one of 3 fuel. So we have a 2 factor, the launcher or the fuel. Okay, and we want to test for questions A. We want to test whether we have the data here is affected by the launchers or not. It means we want to test the row affect the number of miles or not. The row affect the results or not. Or for the second questions, we want to test the column. Is affect the result, the miles or not. So for questions A, you need to compute all the value Firstly, you need to compute x. Here we call x1 dot. Here we call x2 dot. Please try in the chat box the value here. Here we call x dot 1. Here we call x dot 2. Here we call x dot 3. This is the mean of the rows and the mean of the column. And the grand mean we call x dot dot. One dot here we call the mean. And that means the mean of the whole row and column. This is all the data. Okay. And the sum of the row is here we have m equal 3 and n equal 3. N equal 3 and m equal 3. So the row is mean the sum of x I dot minus x bar, no, x dot dot square. I varying from 1 to n. And here you multiply by m. Let me back to the formula. Row m. Sorry, the index is m. And this is n. Do it on your own. You don't have to remember the formula here. And if you ask me, then I say I don't remember all the formula here. Xi dot. This is dot, not 1. This is dot. So it means you are computing the variance of the questions marks here to x dot dot to the final mean here, and whether you have some significance value. I mean, if some value here is different to others value, it will make the sum of the square of the rows significant large compared to the sum of the square of the error. The sum of the square of the error is all the sum of all. Sum of all. This is stand for the difference of the data to the mean of the row to the mean of the column, and you have a 2 plus because you have a 2 minus, the plus the grand mean because you have a 2 minus. Okay. I from 1 to m and j from 1 to n. And your test statistics for questions A, your test statistics for the row equal the sum square of the row divided by m minus 1 over the sum square of the error divided by n. What is n here? Your n is m minus 1 times n is m minus 1 times n minus 1. Okay, do it and please try the answer for the first column, the second column, and the last column, and the first row, the second row, and the last row. Good afternoon, He, me, Tung Anh. Okay, we have almost all students except mine. All right, please write out the answer for all the values here. Firstly, just answer for the questions, the mean of the column. Ask that J and ask I dot. Thank you, Thư. Thank you, Thư. So I will write out the answer of Thư here. So Thư, the mean of the row one, the mean of the row one, 73.53. The mean of the row two, 79.8. The mean of row three, see 86.97. The mean of the column one, 80.33. The mean of column two, 80.07. The mean of column three, 79.9. Okay. And the grand mean. The mean of all the metrics. Thank you, Thư. 80.1. Thank you, hey, 80.1. Good, good, good. So do it, then you will not fall asleep. Actually, this question is not difficult, but I mean, if you learn it on your own, like you read it at home, you may be confused by the notation. One factor and two factor, because you may confuse it like dot and bar here. And last time we have an X bar, right, for one factor. Then compute the variance. Actually, we call the sum square of the row, but actually this is the variance of the variance of the mean of the rows. Thank you, He. So he give the answer. He give answer. Okay, I copy down the answer by Yahi here. Yeah. And compute the sum of the square. The sum square of all the errors, all the errors of all the data. So it stands for the variance of all the data to the means on the rows and to the means on the column. But you have a 2 minus here, so you need to have a 2 plus. So it's that time. Anyone already have the answer for SSE? The sum square of the error. You need to compute 9 values. Thank you, Tung Anh. Thank you, Hey. Okay, so I'm using your answer. Actually, I don't know, but I believe in your calculation. 76.37. Then how about the test statistic for the row? It means for questions A. We want to study whether the launchers affect the mile travel or not. The numbers are the mile travel. So each number here has two properties: hai thuộc tính, fuel, and launcher. Thank you, He. He compiled the test statistics for the row. This is 7.1. 7.1. Okay, I just read out 7.1 here. And what is f of 0.05 m minus 1 and thank you, Hey. 6.94. So the test is greater than 6.94. Then we reject. So the conclusion, please double check your calculation. So we reject the null hypothesis. The null hypothesis means all the rows are the same. The null hypothesis is no difference between the logers. So we reject the fact that no difference between the logers. It means there should be some logers different to other logers. Okay, so it means the loger, the factor loger actually impact on the result. The effect, the loger actually have a significant effect for the result. The result is the mile travels. H0 means no difference between logers. I just say between rows. Between rows. Okay. Now, in order to do B, for B, you need to compare SS column, the sum of the column, and then you compare the test statistics for the column and compare to the F value. Thank you. Oh, the sum of the column is so small. Let me see. Why is so small? Yeah, 80 and 79. So the kinds of the fuel. So we see three fuel here. They are so close. The result are so close. The mean of column 1 and the mean of the column 2, they are all close to 80. Yeah, so that's why the sum square of the column is very small. And the test statistics for the column is small. So it should less than the F value, the threshold value. Okay. And we should accept the fact that there are no difference. Accept means we cannot reject. We do not have enough evidence to reject it with such a few data here. Okay, so the answer for A is reject. B, accept in the quotation mark, mean not reject, more exactly. When we accept something, it does not mean is a true. We do not say about true here. It means we do not have enough evidence to reject it. And we do not say right or wrong here. So some of you may make the questions in the formula why we scare by the constant n-1 here, because actually when you compute for example, when you want to compute the variance for the mean of the rows, when you compute the variance, you need to divide it by n-1 here. So that's why in the test statistics we do the compensation. So in this formula we do not have a divided by n-1 because we want to emphasize the formula here, just the sum of the squares. Okay, so for SSR we just say the sum of the squares and we do not divide it by any constant. So we will make the sum of the square here to return to the sample variance, to the concept variance later on. When we divide it by n-1, we will make the sum of the square become the variance. And then that's why we say we analyze the variance of the mean of the columns. Sorry, of the rows. This is the row, the mean of the row. In the formula here, this is C, not there's I copied the formula in the textbook by Ross, and this is C, not this is column. I mean they have a typo here. Any questions so far? Any questions so far? This is complicated. Any questions so far? No. No questions, right? Okay, you're good. Oh, okay. We today we have the break a little bit earlier. So actually we done for all the key parts before the final exam, and for the rest we practice. So we have the break a little bit earlier, and we will come back in next 20 minutes and we practice more exercise. I will let you practice more exercise. So for this part, you should do it because when you do it, you get more experience and you have a more feeling about the formula. So in summary, I back to the theory here. In summary, to compute to study the factor, the two factor here. So one factor is the rows, one factor is the column, or sometimes people mention the data like the score, and the score here is depend on like the time you study the factor A and the student one, student two, or some other factor. And normally we say one factor when we present the data on the matrix, we stand for the row or the column. So in order to study the effect of the row, we study the variance. This is when you divide it by m-1, it stands for the variance of the row. This is the mean of the row for the mean of all the data. And if you have a one row has the mean more different, is a significantly different to all the rows, it will make this guy large. And if you have a large data like, and the number of columns is also large, it means you have a more data. Then in this case, it may make the test statistics is large. And in this case, it may lead to the hypothesis. It may lead to the result you reject the null hypothesis. The null hypothesis always noting difference. All the rows are the same. It means all the mean of the rows are the same, are equal 0. All the mean of the rows equal 0. The deviation between the data and the mean. And beta j equal 0 means no column effect or no rows effect. Okay. And we scale by the constant here just to make it is a perfect F distribution. And the test statistics is small or large based on based on the sum of square of the row, and also based on the number of data here. Normally when doing exercise, n is small, so that's why normally you accept for doing exercise. In many cases you accept the result, but in practice n is large, and if you see one row is different to other row, you will reject it if you have a large enough data. Okay, we have the break in 20 minutes, so it's a little bit early for today, and we will continue. After the break, we will practice, and today we finish a little bit earlier. Okay, so we will continue at 2:55. Okay, see you next 20 minutes. For the rest of today, we will finish a little bit earlier. For the rest of the lecture for today, we will briefly, just quickly practice in Python for analysis of variance. Then you should spend more time to do it at home. I do not have a time to organize the calculation in detail for the content of the slide here. So you should I recommend you should organize your own code for Python. Then you can do the homework assignment for quickly. Like you have to write down the code to the Python syntax to compute the stop here, to compute the test statistic from the table of data. You can make you can make some rows and some column. Like one factor, you can make 3 rows, and here another factor, you can make say 4 columns, for example. Then you can compute the mean of the rows and the mean of the column, and you compute the sum of the squares, the sum of the square of the rows, the sum of the square of the columns, and so on. The first one we can practice is, okay, let me share the others. Let me send the link to you. It's just one factor analysis of variance, just the syntax of one factor analysis of variance here. So the first one, this is you can recheck when you do the homework assignment. You should organize your own code to compute the test statistics. Here, we just recheck the result. That's it. We use the syntax one way, mean one factor. Like in this example, I suppose we have only one factor. The single factor is treatment. For the treatment, we have 4 data for people, for example, ABCD with the and we sorry for we have 4 treatments ABCD. Sorry. Chưa mở truy cập. Ok, các bạn coi thử, các bạn truy cập được chưa? Sorry about that. Ok, thôi cho nó tiếng Việt luôn. Lát nữa thầy có việc tí cho nên bữa nay mình nghỉ sớm bù lại mấy bữa trước cho các bạn làm việc tới 5 giờ. Cái one factor analysis of variance thì các bạn tự viết code để tính. Các bạn tự viết cái thầy định chuẩn bị cho các bạn, nhưng mà cái này các bạn tự làm được. Các bạn tự viết cái code để work cho nhiều bài cũng được. Tức là các bạn tự viết code để tính cái variance. One factor thì các bạn một factor thì các bạn nhập data thành cái này 3 cột, thì các bạn có thể xem như là 3 dòng, và các bạn tính cái mean của mỗi dòng và tính cái mean chung và tính cái test statistics rất là dễ dàng, và so sánh cái test statistics với cái F value. Cái trong này thì thầy không có tính sẵn cho các bạn, nhưng mà dùng cái lệnh để tính luôn cái p-value, tức là cái này chỉ nhằm mục đích là mình check lại cái mình tính, cái test statistics của mình tính có đúng hay không. Và các bạn dùng thẳng luôn các bạn import cái one way analysis of variance. One way tức là one factor. Ở đây các bạn có chỉ có một cái factor là treatment, mà cái factor là có bốn dòng data, 4 dòng dữ liệu. Có nghĩa là mỗi dữ liệu này là chẳng hạn như thời gian để người ta hồi phục thì nó chỉ có một thuộc tính là một cái treatment, chẳng hạn như vitamin C, một cái treatment, chẳng hạn như là tất cả là đều dùng một cái loại treatment nào đó. Thầy cũng không có rõ cái treatment này, có thể là vitamin C chẳng hạn. Mình có treatment A, treatment B, treatment C, treatment D, và cái thời gian này là thời gian hồi phục. Thì mình test thử là liệu cái treatment nó có ảnh hưởng đến thời gian hồi phục. Tại vì cái data này nó rất là rõ ràng là nó có cái sự khác biệt. Chẳng hạn như cái treatment D là rất là kém, thời gian hồi phục rất là tệ, và treatment A này thời gian hồi phục rất là sớm. Thì có nghĩa là các bạn dự báo là kết quả là phải có sự khác biệt, có sự khác biệt giữa các cái treatment. Thì các bạn tính cái F value, nhưng mà yêu cầu là các bạn phải tính luôn cái test statistics, tức là ở đây thầy chưa kịp làm, nhưng mà các bạn tự tính là các bạn phải insert cái code, tính cái test statistics, từ cái one factor này nè. Thầy đang share lại cái slide. You need to compute the test statistics here. So let me insert the test statistics mentioned in slide 7. Test statistics in slide 7. Còn ở đây mình tính thẳng luôn cái p value. Thì p value này nó rất là nhỏ, có nghĩa là mình reject cái null hypothesis. Null hypothesis thì lúc nào cũng là không có sự khác biệt. Rõ ràng là mình reject nó rồi, tại vì ở đây rõ ràng data nó có sự khác biệt. Có cái treatment, cái cách điều trị A rất là hiệu quả và cách điều trị D rất là kém, tại vì thời gian hồi phục rất là lâu. Các bạn có thắc mắc gì không? Tức là các bạn tự insert cái code nha, hay là thầy cho bonus? Các bạn muốn bonus cái này không? Các bạn tự làm nha. Dạ Minh Tư, dạ là bonus hay là tự làm đúng không? Tự làm được đúng không? Đúng ra là thầy làm một bài cho các bạn, nhưng mà thầy nghĩ cái này tự làm được. Yeah, sure. Yeah, ok. Thầy ghi cái nốt ở đây. Ok. Yeah. Compile. Các bạn nên làm để chuẩn bị cho final exam. Còn cái này là tính thẳng luôn cái p value. Thì các bạn tính cái test statistics bằng ở trong cái slide 7 và tính cái p value và so sánh lại với cái p value này. Còn cái lệnh này là tính thẳng luôn cái p value. Thực ra các bạn học cách đổi từ p value này sang cái test statistics cũng được, thì các bạn sẽ làm được những câu là tính test statistics. Ok, cái ý thứ hai, đúng ra là thầy nhập thành một file, nhưng mà thôi lỡ rồi, thầy sẽ bỏ thành thầy nhập file sau cũng được. Khoan, ý thứ hai là two factor. Các bạn đợi thì tí. Ok, I will just update the mix. Tại mới update cái thầy mới update cái permission. Ý thứ hai là two way, two factor analysis of variance. Here you have the data, 30 data, and each data here has two property. Mỗi data này nó có hai thuộc tính. People want to study the dependence of the height of plant. After some time, after 2 months, it depends on the water and or the sun or not. So this is still the questions. So it means you have 30 data, but each data here is may depend on the water or the sun. The water is may daily or weekly, and the sun may be low, medium or high. Okay. Có nghĩa là các bạn có data 30 data và mỗi data này nó có hai thuộc tính là nó phụ thuộc vào lượng nước hoặc là mỗi data là chiều cao của cái cây sau 2 tháng và nó phụ thuộc vào lượng ánh sáng hoặc là lượng nước. So we want to test whether whether some properties like the water or the sun may affect the data here, may affect the height. One way you can use is to use directly the least square model, the least square, because the least square actually is compute the variance. You can use the least square model to compute the dependence to compute the linear dependence of the height on the water or on the sun. So you compute directly the p-value. So this is another way, not exactly this way, not exactly follow the analysis variance, not follow the formula of analysis of variance we mentioned in the lecture. So this is just a kind of additional reference. So you can after do the assignment, you can try to compute the ordinary least square and compute the p-value. So if the p-value is small, if the p-value like for the water, the p-value is small, then you can reject the null hypothesis. The null hypothesis means no difference. And if this is small, it means you reject it. There should be a difference. The difference, statistical difference effect of the water on the height, for example, or the sun is also small, very small. So the p-value for the sun is also small. It means the sun should affect the height of the plant. So the water or the sun should affect the result. The notation, the quotient here stands for the interaction, like both the sun and the water. So this is the new concept. You can skip it. It means people want to study the interaction effect of, like, think about like both effect, whether the two effect here they have the interaction or not. Is it significant, strong or weak? And in this case, we say the interaction effect is weak. But this is new for you, so you can skip this part. This is kind of beyond the content of the lecture. Okay. Today we finish a little bit early, but I want you to practice two-factor analysis of variance. But before doing this, I want to hear about your projects. How many groups? How many groups? So we will have the presentation next week. How many groups you have? Or you can send me in the chat box the group, like group 1, group 2, group 3. I guess you have around 3 groups, right? Or 4, 3 to 4 groups. Could you please send me now the number of groups by send you the information of your groups? Okay, could you please send me the information of your groups? You can work along if you want. So I know how many groups, and I estimate the time for reviewing last time. Okay. Thank you, Minh Thư. How about the Tuấn Anh, Quân, Khoa? Thank you, Quân. So so far we have 2 groups. Tuấn Anh, can you send me the information of your group? Yahi. You can send personally or public. It's okay. Tuấn Anh work along. How about other? Okay, so far we have okay, we have a totally 4 groups. 4 groups. So the presentation around 15 minutes. I don't want to give so strictly. Like if you want to speak more, then you are welcome. So we have a time because we have the small class. So next week, after we review, we will have the presentation for the project, and we done for the course. I will send you the questions for the review session later on. Okay. Today, I want you to practice more on 2-factor analysis of variance. Let's see. Do you want bonus or quiz here? You need to practice on your. Let's see. Quiz. It should be quiz 8. How many quiz we have? Only 7. Yeah. Okay. So you can work by using calculator, by R or by Python. Is whatever is up to you. Because actually this letter is more convenient if we see in person, but this is online, so I'm not sure. I want to make sure you know how to do 2-factor analysis of variance. So I make it as a quiz. You can discuss, you can ask me during working. We are working on the quiz of 2-factor analysis of variance. And when you're done, I will upload the questions file soon. When you're done, we can say goodbye and you can leave the class. We finished a little bit earlier for today. Just wait for me to send you the questions. Okay, I'm sharing the questions for the quiz 8 for today. You have 40 minutes to do it and submit on Blackboard. This is 2-factor analysis of variance. Actually, 40 minutes is too long, but I don't want to make the limit for the time. So for the data here, you have the data refer to the number of deaths per 10,000 adults in large eastern city in American. So it may depend on the seasons, the winter, the spring, and the fall. So one factor is season, another factor is years. And you have you want to do 2 tests. The death rates do not depend on seasons. So it means the column does not affect the data here. The data here is the death rate. And the second test, the factor 2, no effect on the year. Okay, I will post the file to platform soon right now. I made the time 40 minutes, but you can finish in 20 minutes. And once you're done, we can say goodbye and see you next week. I'm sorry that today we finished a little bit earlier. I have some emergency work. And also we already finished all the stuff, so we can finish earlier. So I make the deadline 40 minutes from now. But you can finish earlier.